The physics of friction plays a big role in alpine skiing. Whether to ski racing or freestyle, friction affects the athlete. The friction between the ski and the snow affects the speed at which the skier will travel down the slope. Many factors, such as snow conditions and the base of the ski, affect the friction. There are multiple forces acting on a skier going down a slope. This block represents a skier. They are affected by the normal force, the force of gravity, and the force of friction. As you can see here, the net force is equal to the sum of the force of friction and the force of gravity on the x-axis. When the equation is rearranged for acceleration, you can see that if the friction coefficient is larger, the resultant acceleration will be smaller. Therefore, friction affects how fast or slow a skier can accelerate. Many skiers, especially ski racers, use skied wax, also known as glide wax, to minimize kinetic friction. A variety of glide waxes are made for specific temperature ranges and other snow conditions, with varying wax hardness and other properties that repel moisture and dirt. The hardness of the glide wax affects the melting of the snow to lubricate its passage over the surface and its ability to avoid suction from meltwater in the snow. Too little melting and sharp edges of snow crystals, or too much suction, impede the acceleration of the ski. A tipping point between where crystal type dominates sliding friction and moisture content occurs around -4 degrees Celsius. Harder waxes address colder, drier, or more abrasive snow conditions, whereas softer waxes have a lower coefficient of friction but abrade more readily. In competitive skiing, friction can cost you a medal or even an injury. For example, if a ski racer applied soft wax the night before a race in cold weather, it would increase friction instead of decreasing it, causing them to ski slower than the other racers.
Who won downhill gold in Garmisch back in 2011 could take Super G in 2017. This is remarkable from Eric Gay. Holds the line, watch the clock, it's Canada!
In freestyle skiing, not using wax on a slow day can cause a skier to hurt themselves on a jump. A typical jump in a skiing train park looks like this. If a skier comes into the takeoff of a jump too slow, they won't make it to the landing of the jump. They'll probably land right here, and that can get them hurt. Here are some videos of what can happen if friction causes a skier to fail a jump. The lab that I have created demonstrates the effect glide wax has on a pair of alpine skis. I was timed skiing a slope straight top to bottom 3 times with no wax, and then 3 times again after applying glide wax. Here's a video of one of my attempts with wax. My average time without wax was 14.45 seconds, and my average time with wax was 13.08 seconds. These results prove that glide wax reduces friction and increases acceleration. Alpine skiing is not the only type of skiing that uses wax. Cross-country skiing is a sport that uses wax, but to increase friction instead of decreasing friction. Because the style of classic cross-country skiing is similar to running, skiers want a section of the bottom of their skis to have grip. Skiers will apply grip wax to the grip zone in the middle of the skis. Here's a video of classic cross-country skiing. A speed trap is an alpine ski course designed for skiers to practice their max speed. This is what a speed trap looks like. As the skier is accelerated down the hill by the force of gravity, 9.8 meters per second squared, their gravitational potential energy is converted to kinetic energy, the energy of motion. In the ideal scenario, all of the potential energy would be converted to kinetic energy. In reality, some of this energy is lost to heat due to friction. The force of friction acts in the direction opposite to the direction of motion, resulting in a lower velocity and hence less kinetic energy. As I talked about earlier, the kinetic friction can be reduced by applying wax to the bottom of the skis. This reduces the coefficient of friction. The second type of frictional force acting on the skier is air resistance. The drag force is proportional to the cross-sectional area of the skier, and the square of its velocity and density relative to the air the skier is traveling through. To go faster, a skier must try to reduce the cross-sectional area of their body. Downhill skiers can adopt more aerodynamic positions such as tucking, and ski racers wear skin-tight race suits to reduce drag. Here is a photo of a ski racer in a skin-tight suit doing a tuck. This concludes my ISP on the physics of friction in skiing. Thank you for watching.